Only 2 questions. I look at the statistics. Also, go through all your answers. There are 4 questions. There are 3, 4, 5. Yeah, 3 to 5 students missed those 4 questions, but 2 of them relatively easy, so I do not want to talk about it. Yeah. Another 2, I want to explain a little bit. Yeah. First one, this one, 3 students missed this one. Answer is 9. Yeah. But those 3 students give me answer 8. The reason 8, because they take log base 2 directly. Log base 2. Yeah. Yeah. So when I talk about the worst case, remember we spent a lot of time in class to derive the exact formula for worst case. This people, so why so many people use this version? Because it comes from log base 2 of n. This is approximation. Yeah. So many times people write it in this way, but that's the approximation version, not exact version, right? Yeah. If you treat it as an approximation, then no problem. It's correct, right? Especially when n is large. Yeah. So most people use this approximate version. But in this question, first, our n is not large. Second, I want you to give me the exact answer, not approximate answer. Yeah. So for that reason, remember we have 2 formulas. Yeah. One is, if you use the ceiling function, log base 2 of parenthesis n plus 1. Yeah. N plus 1, not n. All right? And the ceiling function. And another equivalent, yeah, same value, but it is 1 plus floor function, log base 2 of n. Floor function, but you need to add 1 more. Yeah. So that way, then that's the exact. So I choose this. Yeah, this is a power of 2. Yeah, power of 2. So then, try to, confuse some of the students. Try to check, because only when n is power of 2, then the formulas here and the approximate formula, there is a difference. Yeah. Otherwise, so even you use the wrong formula, you may still you get a correct answer. Okay, if it's not power 2, so you use the wrong formula. Okay, so here, yeah, floor ceiling function. Yeah, so you may still get the correct answer. Yeah. All right. So that's this question. Another question, the last question. Also, 3 students missed this one. The answer is false. Yeah. The reason is this sentence: one can always find an optimal algorithm. Yeah. Oh. Yeah. I need to mute it. Yeah. A lot of spam thing. Yeah. Yeah. So I need to quickly mute it. Yeah. So airplane mode. All right. Yeah. So one can always find. Yeah. But this is, remember, this is our lower bound. For comparison sort, we know the number of comparisons should be greater, or must be greater or equal to this lower bound number. Okay? Yeah? That's our result. Yeah. Yeah. We can prove it. Yeah, this semester I do not have time to prove it. Yeah, but we can prove it. All right? Yeah. But another question, you have this lower bound. It does not mean you can reach this lower bound. Because reaching this lower bound very hard when n is large. N large. When n small, yeah, so we can do it. Okay, we did it. Yeah, for n small number, 4, 5, even 6, 7, we can we can all make it. We can all get a lower bound. Yeah. But when n is relatively large, nobody knows how to get a lower bound. Okay? Yeah. And nobody knows the answer if it's possible to get this lower bound. Yeah. Okay? So that's different. So that means, yeah, find an optimal algorithm that sorts with, yeah. But there is another meaning behind it. So here, there are several meanings. Actually, there are several meanings behind this sentence. Yeah. All right. First, yeah, I already talked about, we don't know if we can reach this over. The second one, another thing is, even if one can find an optimal algorithm, yeah? So even if one can find, but that optimal algorithm, that number could be greater than this one. Okay? We only say greater or equal, but it's not guaranteed, right? It is not guaranteed. The optimal algorithm should equal to this number. Yeah. Nobody knows that. Okay? And nobody knows that. Yeah. Even if you can find an optimal algorithm. Okay? Yeah. You only know that number is greater or equal to this one. Yeah, but you cannot. Nobody can, rigorously prove this result. So that's why. So we can only say false. Yeah, we can only say false. All right? Yeah, so here, yeah. Oh, another, yeah, for the question like this, yeah. Let me talk about the logic. For the question like this, let me talk about the logic from the, logic point of view, the question. True or false? True, when we answer true, we mean this. First, we know the answer. And it is true. The statement is correct. And we know, we can prove it. We can prove it is correct, right? Yeah, that's true. All right. Now there is a possibility. Yeah. We don't know this statement correct or not. Nobody knows. In that situation, do you choose true or false? Nobody knows the statement correct or not. Then, by logic, we should choose false, right? Yeah. Because when you choose true, because nobody can prove it, how can you choose true? Right? That's the logic. Yeah. But there is a possibility in the future someone can prove it. It is true, right? Yeah. So there is a possibility someone could prove it. It is correct in the future. But we cannot rely on that, right? Yeah. So here, this question like that, this question, we don't know the answer. Nobody can prove it's true. Then under this situation, based on the logic, we need to select false. Yeah. Right? Yeah. But there is a possibility after several years, then someone can prove it. It's correct. Then we will say it's true. But only after it is proved to be correct, right? Yeah. So here, we have this kind of situation. Okay? We have this kind of situation. Yeah. All right. So that's the comments for the quiz questions. Next, I want to go to the computation questions. Yeah. For the computation questions, yeah, I look at a few students. Yeah. So I'm doing grading, but in order to explain the questions, yeah, so I look at the 3 students. so your answers, so then I can make some comments. So I want to have an overview of the general questions. Yeah. All right. Yeah. So based on my impression, so there are several, because in this class we have several results, right? Yeah. Yeah. We have some existing results. Yeah. So when we solve those questions, especially challenging questions, we need to use those results. Yeah. But I noticed that some students didn't realize, we can use those results. Some students still doing things from scratch. Okay? Yeah. 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 All right. So here, let me review those related results before we go to the concrete questions. Yeah. All right. The first one, sort 4-element array. We have that result, right? Yeah. Sort a 4-element array and we know 5 comparisons, right? Yeah. We need this question, 5 comparisons. And this is optimal, right? Yeah. Yeah, we have a question. Yeah, we have a question. Our second question, part B, second question. That question, I give you 4 elements, but I give you 2 inequalities. Yeah. But so you need to use these results. Yeah. Without the given condition, we need 5, right? Yeah. But with given conditions, 2 inequalities, and both inequalities can be used in our sorting. Yeah. Both are useful. Yeah. Then your answer is 5 minus 2 equals 3, right? Yeah. Because you already have 2 of them, right? Yeah. 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 This method, many people know this method, but there is a condition. The 2 given inequalities can be completely used. Yeah. Sometimes some of the given condition may not be useful. Yeah. Sometimes some of the conditions, you can only partially use, not completely use. Okay? Yeah. That could happen. In that one, then when you use this method, your answer will not be accurate. Yeah. From last homework assignment number 1, many students use the way they try to convert a given condition to a certain number of comparisons, equivalent number of comparisons. But that conversion is not accurate. Not accurate. Yeah, because our given condition too complicated. Too complicated. You cannot easily convert it to, certain number of comparisons, right? Yeah. Yeah. Not accurate. But this question, very easy. Our given condition not complicated, very simple. So we can convert it. Yeah. All right. What's wrong? I remember I run the alarm, not alarm, timer. Oh, yeah. Oh, yeah. Let me reset. Now. Yeah, reset. I need to. Cancel. Oh, yeah. All right. Yeah. So that's one. And there is another one, result. Find the median of 5, right? 5 elements. That one, 6 comparisons. Yeah, so that one. Okay, we need to use that result. All right. Remember, top 2, not it. Yeah. So remember, we have a question. Yeah, we need to find an element not in top 2 and not in bottom 2, right? That question. So we need to select 5 elements, not in top to bottom. But I also give you some condition, 2 inequalities, right? Yeah. So we have condition, 2 inequalities. And those 2 inequalities can both be used when we find the median, right? So that those 2 can be completely used, can help us save 2 comparisons. So the answer is 6 minus 2 equals 4. Okay? Yeah. Yeah, but I notice some students, didn't use this result. Okay? Yeah. I noticed some students, now, after I look at the answer, their final answer correct. Yeah. But they start from scratch. Okay? Yeah. So do all the details. Compare first one, second one, write the whole page, more than 1 page. Yeah. Yeah. But I need to check. I need to check the details if it's correct. Yeah. But at the end, the answer is correct. Yeah. Okay. Yeah. But here, if we use existing, we just write a few lines, right? Yeah. We don't need to start from scratch. Yeah. So that's what I mean. Yeah. Especially for you. You have part B, you need to complete in class, right? 10 questions in class. If you start from scratch, how much time do you need? Right? If you need half an hour, right? But if you use existing result, we just need 5 minutes, right? First we need to make connection. Then we organize our logic, right? Then we write down, 5 minutes. Otherwise, you need to go through all the details. That's too much time. Yeah. So that's why get familiar with our existing results. Very important. Yeah. All right. That's the second one. The third one, find the second largest element, right? That one. Okay. That one, yeah. So we use that formula a lot. Okay, find the second largest element, right? Yeah. The formula n plus ceiling function, this minus 2, right? Yeah. We have that formula. Tournament method. Yeah. We derive it in class. We prove it in class. And this is optimal. Okay? Yeah, this algorithm is optimal. Yeah. So we want to use it. So then remember there is a question. We need to find an element in an array with 300 something elements. Yeah, that number is not important, but not max. Yeah, we need to find element first and not max. Second, not in bottom 2. Okay, not max, not in bottom 2. Right? Yeah. All right. Yeah. Then you need to select 10. Yeah, because bottom 8, right? Yeah. So we need to select 10 elements, right? Because if you select 10 elements, you need to, get the top 2. All right. Then bottom 8. Top 2, the bottom 8. So now you target this one. Okay? Yeah. Second largest among these 10 elements. Yeah. So you plug in. Yeah. So 10 plus log base 2 of 10, seeding function minus 2. This is 4, right? Yeah. Because greater than 3 point something. Okay. So seeding function 4. So equals 12. Yeah. But I noticed many students didn't apply this formula and give me the number much greater than 12. 12 is the best answer, best solution. Yeah. Some students give me, a very large number. Yeah. Yeah. So you need to be familiar with all our existing results, and you need to make connection to it. If I mention this result, now you can recall it. But when you do the problem solving, you cannot make a connection to it. Yeah, that's another question. You cannot make connection to it. Okay? Yeah? All right? Yeah. All right. So that's the first 3 results. Then another 2 important results. Yeah. Especially when you work on the challenging questions. Now, when you work on the challenging question, there are another 2 results we need to use. All right. So result number 4. Binary insertion. Yeah, binary insertion. Okay, yeah. So, for example, we have an ordered array. Okay, yeah, with 3 elements. Okay, yeah, yeah. X3, X2, X1. All right. Then we want to insert X4 into this ordered array with a minimum number of comparisons. We need to do the binary insertion. Okay. We compare X1 with X2 first, the first comparison. Okay? Then the second, based on greater or less than, so you have 2 cases, but you just need 2 comparisons. You can insert it into this ordered array. Okay, not a 3, 2, not a 3. Okay, yeah. So this result, so you need to be aware of. Yeah. In homework assignment 2, in the last 3 questions, I'll give you 3 challenging questions, not 5. Yeah. In the final year, we have 5. Homework assignment number 2, you only have 3. Last 3, you all need to use this result. All 3, you need to use this result to get, good solution and very fast. Yeah, because you can find solution very fast. Yeah. So this is number 4. Number 5, another commonly used result, and you have a very good chance to use in the challenging questions. Also in the challenging questions. What's that? Partial merge operation. Yeah, I talk about, but many of you, didn't realize the importance. Yeah, all right, partial merge. Not a full merge, but it's a, general case. Full merge, just a special case of this partial merge. So we do not complete the merge. As soon as we find the element we need, we stop immediately. Yeah, that's the partial merge. We still run the merge operation, but you know, we need, as soon as we get a solution, we stop immediately because we already get a solution. Why we need to do more work, right? Yeah, the logic is so simple. Okay, partial merge operation. Okay, now full merge. Yeah. Yeah, from the name, you know how to do it, right? Yeah. Yeah. So, for example, two ordered arrays. Okay? All right. So one is ordered x3, x2, x1. Okay? All right. Another x, so 7, x6, x5. Okay? Yeah. Two order arrays given, right? The x4 unknown, right? x4 unknown. Okay? All right. First, can we apply binary insertion to insert x4 to the first ordered array with two comparisons, right? Yeah. Yeah. So existing result. After that, we will get a new ordered array, right? Yeah. So let's assume x4, x3. Yeah. Because we just need a representative case, right? Yeah. Yeah. Although there are many cases, but the detail of the cases is not important. We just need an ordered array with 4 elements. Yeah. So we just pick one. Okay. All right. Then, in these two ordered arrays, our goal, we find the median, right? Yeah. Because that question number 13. Our goal, we need to find the median. Find the median. What's the median? Fourth largest, right? Median is the fourth largest. Fourth largest in these two order array, we just apply the merge, but we do not need to complete the merge. Okay? Merge the whole array sorted. We don't need. As soon as we find the median, we stop. Okay? All right. Now we can do the first comparison. We compare the top two. One comparison, first comparison, we get the max, right? Then the winner is the max. The loser we use to compare to the, next element in the other ordered array. Yeah, because the winner, we remove it from the consideration. Winner. Then the next immediate element in that ordered array will be used to do the second comparison, right? So second comparison, the winner is the second largest, right? Second largest, all right? Then another comparison, winner third largest. Then comparison number 4, is that a median? And after we get a median, we do not need to do any more comparison, right? We already get a solution. So we should stop immediately. That's why we call it a partial merge, right? Yeah. So this is the partial merge operation. Okay. All right. So because the binary insertion step we need 2. This partial merge, this step we need 4. So the total 2 plus 4 equals 6. Answer. Yeah, you need to use these 2 results. Right? So simple. Yeah. 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 Try. Yeah. Some students. Yeah. So I saw the answer correct, but without using existing results. Long work. Long work. Yeah. It's a lot of comparisons. But, these challenging questions I'll give you online. So if you spend not in class, so the question like this won't appear in part B in class. Yeah. So otherwise, too much time you can think about. Yeah. Too much time. Right? Yeah? So, yeah. So that's why I want to review these 5 very important results. Okay? But there is one I didn't give you in this homework assignment number 2. So let me put it here. Number 6. Sort 5-element array. With 7 comparisons. Yeah. Yeah. And we know how to solve, how to do it. Yeah. So we did it in class. That means you treat it as an existing result. You can use it in the final. Okay? Yeah. So we know all those 7 comparisons, finding the solution. No, you just use it. No. You do not need to spend a lot of time really to do the sorting, right? Yeah, because we know the details. Yeah. We know how to sort it, all right? Yeah. You just talk about it, okay? Yeah. Okay? Yeah. So in the final, there is a chance, okay? In the final, there is a chance. You may need to use this result. Okay. All right. Now I want to jump to our concrete questions to make some more comments. Yeah. So there are some more questions. Yeah. I will post the solution file. Yeah. So today. I cannot go through all the questions. It's impossible. Yeah. But for most of the relatively easier questions, you just study my solution. Should be good enough. Yeah. For relatively hard, some ideas, thinking, a little deep. So I want to explain here. Yeah. 2 questions, remember I mentioned in the 1 hint, so 1 hint session, I talk about 2 questions. Yeah. So I want to give you the result here. Yeah. So let me switch to my annotation software, PDF annotation 1. Yeah. So get out to those PowerPoint slides. Yeah. So then go to here, PDF. All right. First, I want to look at these 2 questions. Yeah. Remember, I talked about greedy algorithm. Okay. Yeah. So when you do it. So you see, we covered many questions already. Yeah. Number 9, number 10. Now I want to talk about number 9, number 10. These 2 questions. Okay. Yeah. All right. Yeah. So in the final, you will have these 2 questions. All right. Similar of these 2 questions. Yeah. I will modify. So here I want to make sure when you see these 2 questions, so you can, get a full credit. Yeah. All right. So these 2 questions, you can see you have the version 3 ordered, merged 3 ordered arrays. But in our final, your 3 number will be changed to 5. Okay. much larger, 5. You need to merge 5 ordered arrays, one for best case, another for worst case. Yeah. Then, if you do not know the smart way, too much work. Because these 2 questions belong to the part B, basic computation questions. You need to do it in classroom, all right? Within 2 hours. But if you want to exhaust all the possible cases, think about how much time you need, right? So it's very hard to exhaust all the possible cases. Well, you have 5 arrays, right? Yeah. Only 3 cases. So you do not need too much time. 3 cases. But 5, think about how many cases you will have, right? Yeah? Think about it. Yeah? So, yeah. All right. You need to find, one optimal method. Yeah. Greedy algorithm. We know greedy algorithm in general may not give us optimal, but in special cases, it can give us optimal solution. These 2 questions, these 2 cases, we can apply greedy algorithm to get optimal solution. All right. Yeah, so here I want to tell you how to do the greedy algorithm. Greedy algorithm to get an optimal solution for the best case, worst case. These 2 cases, our greedy strategies will be different. Greedy strategies will be different. Okay? Yeah? All right. So now, here for best case. So what's the greedy strategy? Yeah. I need to give you the greedy strategy. All right. Before you apply, you need to, sort. Yeah. These 5 ordered array. Based on the array sizes, sort the sizes in ascending order, right? Yeah. Okay. Yeah. Or I do not say sort, arrange the sizes in ascending order. Then we can apply greedy strategy. Okay? Yeah. All right. Yeah. Each time, yeah, we only need to define our strategy for each time, right? Yeah. Every time, each step, how to apply greedy strategy. Okay? All right. So, yeah. So each merge step when we have a list of ordered arrays, we need to pick 2 from the list, right? Yeah. So arrange. So we have a list of ordered arrays. But how to select 2 arrays from the list? Our greedy strategy is select the shortest array, okay? Yeah, the first one is the shortest and the longest. Two arrays, okay? Yeah, array, yeah, longest, yeah. I don't want to make you confused. Yeah, yeah, yeah. You need to merge two arrays, right? Two ordered arrays, shortest and longest arrays. That's the greedy strategy. Okay, yeah. But after you merge, you get one. You put it back, right? Yeah, because you get a longer ordered array. Then you put it in the right position because you need to maintain a list of ordered arrays, right? So that size you add together, you need to put it back in the list, in the right position, right? Because in the next step, you need to select shortest and the longest. Then merge, you have a size, then you need to insert back to your list, okay? Until, yeah. For five, yeah. So here, the 5, let me give you a simple example for 5, all right? Yeah, all right. Simple example, 5, okay? Let me use smaller number, how about that, okay? 2, 4, 7, 11, 19, how about that? This is our list. Let me apply the greedy strategy on this example, all right? Based on our strategy, the first one, we need to merge shortest and the longest, all right? Yeah, merge, the first step, merge 2 and 19, how about that? 2 and 19, all right? Yeah, 2 and 19, the result, number of comparison minimum, right? Because this is for the best case. The result minimum is 2. The size is 21, right? Size 21, right? So this 21, you need to put it back. Yeah. So your list, now you update your list, okay? Your list, because you already used the array with the size 2 and array with the size 19, you cross out these two arrays, okay? Yeah. So you update your list. You have 4, 7, 11, 21, okay? Yeah, you update it, all right? So the next step, you apply this strategy. You select array with size 4, array with size 21, all right? So merge size 4, size 21. So you will get number of comparison minimum is 4, array size 25. Okay, array size is 25, all right? Yeah. So then you need to update, right? So remove, but you need to add that 25, the size here. Okay? All right. Step 3, so you merge array 7 and 25. So 7 minimum and the size 32. Okay? All right, 32. So you need to cross out, yeah. So the last step, you only have 2 arrays, ordered array left, 11 and 32. So the step number 4, so you merge 11 and 32. Number comparison minimum 11 and the size 43. Okay, all right. Then you add a total and you add up the first part of the numbers. So total 2 plus 4 plus 7 plus 11, right? Yeah. So 6, 13, 24, right? Yeah. See, that's the answer. Okay, the minimum. All right? Yeah. Yeah. Greedy strategy. Okay? Yeah. You do not need to try so many cases. Yeah. And it can be proved it's optimal. Yeah. So it can be proved. Yeah. We need to prove. We can use mathematical induction to prove it. Yeah. Yeah. All right? But here we do not need. Yeah. We can use mathematical induction to prove it. Yeah, now the worst case. Worst case, the strategy should be different. Yeah. Yeah. So you run the same process, but when you select 2 arrays from the list, the strategy is different. Then, yeah, the remaining work, yeah, the strategy here, okay, the greedy strategy we define in this way. Okay, all right. Each step each merge step, we know, select two shortest arrays to merge. Good. That's simple. 2 shortest. Yeah. That's for the worst case. Okay? This is for the worst case. The best case, 1 shortest, 1 longest. So different strategies. Yeah. 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 So why is that? Because the formula is different. Okay? Yeah, formula is different. So when we want to get a minimum number comparisons, yeah, we need to look at the formulas. Okay? So the structure of the formula tells us we should take this strategy. Yeah. We should take this strategy. The formula tells us what is the right strategy to take. Yeah, so here. Yeah, so this strategy now, I think I do not need to run it another time, right? Yeah, so you know how to do it. I do not need to show you how to do it. Yeah. Then in the final 2 questions, merge 5 ordered arrays. Yeah, you have 2 questions. So you apply these 2 strategies. Yeah, you can find the answer quickly. Yeah. Yeah. Otherwise, too much time. Okay. Yeah. All right. Yeah. So let me look at other questions because we do not have much time left. Yeah, but I covered many questions. Yeah. For some many easy questions, I think I do not need to spend time. Yeah. I just use my time on the relatively hard questions. Yeah. All right. Yeah. So, yeah. Oh, yeah. I mean, these, tedious work, but not hard. Okay. Although tedious work, but not very hard. Yeah. So I want to talk about the, last 3 questions. Number 13, I already did it, right? When I explained, the first part, the existing result. We did it, okay? Yeah, binary insertion, then partial merge. Yeah, all right. Then the next one you can see same idea. Binary insertion, and this time we need to do full merge. Yeah, because we need to sort, right? We need to sort. Sort means we need to sort. So we need to do full merge. All right? Yeah. Yeah. So, yeah. And you can see from the structure, I hope you can identify. Yeah. Easy to identify, yeah? Because I gave you 2 ordered arrays, but there are 2 elements not in the ordered array. Element number 4 and element number 8 not in the ordered array. So we need to do insertion. When we do insertion, we need to apply binary insertion. Right? Yeah. So, all right. So x3, x2, x1. Then X4, we do binary insertion. Yeah. We need two comparisons. Okay? All right. Then this side, X7, X6, X5, we need to do binary insertion here. We need another two comparisons, right? Yeah. After these four comparisons, we have two order arrays with each one 4 elements, right? 4 elements. Then we merge two ordered arrays for the worst case. Our formula 4 plus 4 minus 1, right? Equals 7. Okay? Yeah. So the total comparison, you need 2 plus 2 plus 7. 11. Okay? Yeah. 11. All right? Yeah. Yeah. All right? Yeah. All right. So you can see how frequent we use these two results. Okay? How frequent we use these two results. Yeah. One binary insertion, one partial merge. Okay? All right. The last one, yeah, also similar. Okay? Yeah, the last one. Last one, find a median, yeah, but slightly different. So we need, question? Yeah. All right. Yeah. All right. Yeah, the last one is slightly different. Yeah. All right. Yeah. So let me explain the last one. Yeah. Yeah. Last one, we need to do some lot of preparation work. Yeah. So then we can apply these two results. Yeah. All right. The last one, yeah, we already have two ordered arrays, yeah, but not covering all the elements. Okay. Yeah. 4 elements here. Yeah. So X4, X3, X2, X1, X9, X8, X7, X6. Okay, all right. And X5, yeah, unknown, right? X5 unknown. All right. Yeah. First, we compare X2 and X8. Yeah. Although you have many different ways. Yeah. So this way we try to balance. Okay. So here, yeah, based on the experience, sometimes, you know, this is some balanced way. Yeah. All right. So this is our first comparison. All right. First comparison, then there are 2 cases. Case 1, X2 greater than X8. Case 2, X2 less than X8. Okay, all right. Greater than, yeah, the diagram like this. Well, the diagram like this. Yeah, X2 higher than X8. Okay, yeah. This one. Then we do elimination. Okay, elimination first. You can see X3, X4 can be eliminated. X3, X4 greater than X1, X2, then the other side, X6, X7, X8. 5 elements, right? Yeah. But the median equals fifth largest or fifth smallest, right? Yeah. So when you see, some elements greater than at least 5 elements, cannot be the median, right? Yeah, cannot be the median. Yeah. All right. Similarly, Similarly, these two elements, okay, yeah, x6, x7 less than x8, x9, then the other side, x2, x3, x4, also 5 elements, right? So these two cannot be the median. That means these 4 elements can be eliminated. Okay, can be eliminated. All right? Yeah. That's case 1. But case 2, our diagram becomes this. Like this, okay? Yeah. Then elimination, you can say, yeah, x9 greater than at least 5 elements. x9 greater than x1, x2, x6, x7, x8. So x9 can be eliminated, right? Then x1 less than at least 5 elements. x2, x3, x4, the other side, x8, x9. Yeah. So x1 can be eliminated from the consideration for the median, but now we want to compare case 1, case 2. Case 1, we can eliminate 4 elements, right? Case 2, we can only eliminate 2 elements. Which one is worse? Case 2 worse, right? The more elements you can eliminate, then you can do better, right? Yeah. But we need to focus on the worst case. Yeah, so we should not focus on the better case. Yeah. That's why we target case 2, not case 1. All right? Yeah. Case 2, now we move to the next stage. Now, yeah. So after first round processing, we move to our second round processing. Okay? Second round processing, yeah, let's clean up a little bit. x4, x3, x2, this side, x8, x7, x6, and we have one link like that, right? Then there is x5. All right. Then in these 7 elements, median equals, yeah, because we one from top, one from bottom, median equals the 4th element, right? Yeah, 4th. Yeah, median. Yeah, median. If you compare with question 13, is it pretty much very close to our question 13? Yeah, question 13. But you have this extra link, a little more information, but this link may not be very useful. Yeah, this link is not quite useful. Yeah, so you just apply question 13. Our answer 6 comparisons, right? 6 comparisons. But in the first round, in the first round, you use 1, right? So 1 plus 6, 7 comparisons. Right, 7 comparisons, yeah. Yeah.
I was thinking it was very similar to the question 13 minutes ago.
Yeah, similar to, you do not need to repeat it. You just apply your solution
I was thinking
from,
about doing that, I'm like, maybe he's tricking me.
all right. Oh, last thing. So before you leave, last thing, yeah. So this 7 comparison, I treat this as our standard solution, okay? Standard solution. So if you give me this solution, then you get a full credit of this question, okay? 7 comparison. But I saw some student do better, okay? Some students give me 6 comparison solution, okay? Yeah. 6 comparison better than, that means better than the standard solution. Then I need to look at if you do it correct or not, right? I need to carefully check your logic, reasoning in your solution. If it's correct, yeah, so sometimes the student can give me the better solution than the standard solution. If it's correct, okay, yeah, if correct, yeah, because you beat the standard solution, so you get 2 bonus points. Yeah, yeah, not just the full credit, other than full credit, 2 bonus points. Okay, yeah, encourage you to do better, right? Yeah, if you beat the standard solution, then you can earn 2 extra bonus points. Yeah. All right, yeah, yeah. All right, that's it. Yeah, yeah. So we pretty much cover all the questions, yeah, in our Part B. Yeah. So then I will update. Yeah, I found some mistakes in my solution file, so I need to update. After I fix those mistakes, then I will post the solution file.